Assalamualaikum and good morning. So today we are going to present about ceramic and electronic. So for introduction, ceramic capacitor are electronic component that use ceramic as the dielectric. They are widely used in electronic circuit because they are too small, reliable, low cost, and provide stable capacitance for filtering, coupling, and decoupling application.
Okay, let's go into the overview of ceramic capacitor. As I did said before, ceramic capacitor is an electronic component that release and stores electrical energy using a ceramic material as a dielectric, which has a fixed value capacitor that consists of two or more alternating layers of ceramic and metal electrodes. Okay, ceramic capacitor consists of two types, which is ceramic disc capacitor and also multi-layered ceramic capacitor (MLCC), which are further classified into two classes, which is class 1 and class 2. Class 1 are made from non-ferroelectric materials and low dielectric constants, which has lower capacitance value and offer near zero drift. However, class 2 are made from ferroelectric, which offer higher capacitance in smaller size. This composition defines the electrical behavior and application that has been widely used in electronic circuits in modern technology. Okay, next is the history of ceramic capacitor. Ceramic capacitor were first developed in 1900 using a ceramic material as a die insulator, which major improvement happens in the late of 1930s when scientists adding titanium to increase the dielectric constant, making the capacitor more efficient. Around 1940, scientists discovered a barium titanium allowed in ceramic capacitor to be used in military electronics because it has excellent insulation properties and the ability to operate over a wide range of temperature. In 1960, ceramic laminate capacitor, or we call it as multi-layered ceramic capacitor, become more commercial product. In the 1970s, the rapid growth of integrated circuits, computers and portable electronic devices made ceramic capacitor more essential component to the world. Today, ceramic capacitor make up about 70% of global capacitor market due to the compact size, low cost and suitable for mass production.
So let's move on to application of ceramic capacitor and their role in modern gadget. Firstly, power supply filtering. The process of employing elements such as capacitor and inductors, it is to filter the power supply signal and eliminate undesired aspects such as the presence of ripple in the power signal. It is to produce a stable direct current DC signal that can be used to power delicate circuits. The process involves removing the pulsating DC from the rectifier, where the capacitor absorbs current during the positive cycle and discharge current during the negative cycles. The inductors resist changes in current flow. This is equivalent to a low-pass filter that allows DC, which is 0 Hz, to pass through the produced a stabilized DC signal. Next, timing and oscillator circuit. It is an electronic circuit that generates a continuous and stable alternating current signal without requiring an external input. They operate using feedback circuit, a resonance circuit, and amplifier to sustain oscillation. By using resistor, capacitor, or crystal oscillator, these circuits precisely control the frequency and timing of the output signal. They are essential in digital systems as they provide a clock signal that ensure reliable and synchronized operation of electronic device. Next, noise suppression is used to reduce electromagnetic interference and radio frequency interference that can be disturbed electronic signal. This unwanted noise can reduce device reliability and overall performance. In addition to basic methods such as shielding and grounding, advanced techniques like noise filter and AC shielding are used, especially in high interference environments. Proper noise suppression ensure clean signal, improve system stability, and extend the operational lifetime of electronic sensor and device. Next, audio and video circuits are designed to process, amplify, and transmit electrical signal that represent sound and visual information. They are essential components in modern devices such as smartphone, television, and sound system. By stabilizing and conditioning signal, these circuits reduce noise, hum, and distortion, resulting in clearer audio and sharper the image. As a result, they significantly enhance the overall user experience in electronic gadget. So next, moving on to advanced capacitor innovation, ceramic capacitor, especially multi-layered ceramic capacitor. MLCC are made by stacking multiple thin ceramic layers together. This layer structure allows them to achieve very high capacitance while occupying very little space. As a result, MLCC are essential for the miniaturization of modern gadgets, helping devices become smaller, faster, and more energy efficient. Next, we have high-temperature ceramic capacitor. These capacitors are designed using advanced ceramic materials that allow them to operate reliably at temperatures above 150 Celsius. This makes them extremely important for automotive, aerospace, and industrial application, where electronic components must be function under harsh and high-temperature conditions without failure. Last but not least, let's look at environment-friendly manufacture. Modern ceramic capacitors are now manufactured using lead-free and RoHS compliant materials. This means they meet international environmental safety standards and significantly reduce harmful substances during production. The key advantage here is that manufacturers can lower environmental impact without compromising performance, making these components both efficient and sustainable for modern electronics. Lastly, moving on to high voltage ceramic capacitor. Advancement in the electric strength have allowed ceramic capacitor to safely handle much higher voltage than before. Because of this improvement, these capacitors are widely used in power electronic and renewable energy systems, where stable operation at high voltage levels is essential for safety and reliability. For example, in laptops and PCs, ceramic capacitor regulate voltage and filter noise in the motherboards and power management circuits. This prevents data errors and overheating of sensitive components. Next, smart televisions. Ceramic capacitor are used in display driver circuits and audio system to ensure the clear image and sound quality by filtering unwanted electrical noise. Next, automotive electronic. In vehicles, ceramic capacitors are used in engine control units, sensors, and infotainment systems. They can withstand high temperature and vibration, ensuring safe and reliable operation. Lastly, medical devices. Ceramic capacitor provides stable and precise signal control in medical instruments such as ECG machine and imaging equipment, where accuracy and reliability are critical.
Ceramic capacitors have many advantages, right? But they also have a limitation. First, they have a limited capacitance value compared to the other types of capacitor. Their capacitance can change with the voltage and temperature, which can affect a circuit stability. Next, ceramic capacitors have a limited voltage range, which it is not suitable for the high voltage application. Third, they are also sensitive to a temperature changes. It can cause a variation in capacitors that can reduce the accuracy in a high precision circuits. In addition, class 2 ceramic capacitors such as X7R and X5R can show a piezoelectrical effect, which can produce unwanted noise such as in electronic circuits. Lastly, larger multi-layered ceramic capacitor can crack due to vibration, mechanical stress, moisture absorption, and other environmental factors that can lead to the circuit's failure.
So for future trend, ceramic capacitors are expected to become smaller with high capacitance and improved temperature stability. Advance in material and manufacturing technology will allow their wider use in high frequency, high power, and advanced electronic devices such as electronic vehicle and 5G system. There are still other examples that I will be talking about for the next slide. For the first feature trends, it is electronic vehicle. Ceramic capacitors are used in power control units and battery management system because they can withstand high temperature. For the second one, 5G system. Multi-layer ceramic capacitors are used for high frequency signal stability in smartphone and 5G base station. Here are other three examples for feature trend. For the first one, space technology. Ceramic capacitors are preferred for satellites and space equipment because of their radiation resistance for durability. For the second one, AI, artificial intelligence. High-speed ceramic capacitors are needed for stable power delivery in AI processor and data centers. For the last one, robotic and automation. Ceramic capacitors support precise control system and in industrial robots. That's all for future trends. So, for the conclusion for our presentation, we can conclude that ceramic capacitors play an important role in electronics due to their durability, fast response, and stable electrical performance. We highlighted the basic structure advantage of ceramic capacitor, This advantage makes them significant component in modern electronic technology and essential for a wide range of electronic applications. That's all for our presentation, and thank you.